The colonization of Jupiter's moon Ganymede is a fascinating concept that combines both science fiction and emerging scientific possibilities. While Ganymede itself is not currently colonized, there have been various theoretical discussions and speculative ideas surrounding the possibility. Here's a detailed breakdown based on current scientific understanding, proposals, and future concepts. Basic information about Ganymede. Size and composition. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. It has a diameter of about 5,268 kilometers, 3,273 miles, and is primarily composed of water ice and rock. Atmosphere. Ganymede has a very thin atmosphere, mostly made up of oxygen, but it is far too thin to support human life. Magnetic field. Ganymede is unique among moons because it has its own magnetic field, which is believed to be generated by a liquid iron-nickel core. This could potentially provide some level of protection from harmful radiation. Challenges of colonization. Colonizing Ganymede would require overcoming significant environmental and technological challenges. Extreme cold. Ganymede is located far from the Sun, and its surface temperature averages around 160 degrees Celsius, 260 degrees Fahrenheit. This would pose major challenges in terms of habitat construction, energy generation, and life support systems for colonists. Radiation exposure. While Ganymede has a magnetic field, it's not strong enough to provide full protection against the radiation belts of Jupiter, which are highly intense. Colonists would need to be protected from radiation, likely through thick shielding or underground habitats. Limited resources. While Ganymede has large amounts of water ice, its natural resources would still need to be carefully managed and supplemented by advanced mining technologies for elements needed for construction and life support, e.g., metals, oxygen, and nitrogen. Distance from Earth. The average distance from Earth to Ganymede is about 628 million kilometers, 390 million miles. Current space travel technology would make getting there a significant challenge, taking years with present propulsion systems. Advanced propulsion technology would be needed for efficient transportation. Potential methods for colonization. Transport. To colonize Ganymede, advanced spacecraft would be needed. Concepts such as nuclear fusion or ion drives might be used to make interplanetary travel feasible. The journey from Earth could take several years, depending on the propulsion system. Surface habitats. Given Ganymede's thin atmosphere and cold environment, colonists would need to build protected habitats, either underground or in domed structures, to shield them from radiation and provide a livable temperature. These habitats would require life support systems for air, water, and food. Energy generation. Solar power would likely be insufficient due to Ganymede's distance from the Sun. Colonists would need to rely on nuclear power, possibly fission reactors or even future fusion reactors. Geothermal energy could be another possibility if there's sufficient geothermal activity beneath the Moon's surface. Water and oxygen. Ganymede has vast reserves of water ice, which could be mined to provide water for drinking, oxygen production, and even hydrogen for fuel. Extracting and processing this ice would be one of the primary methods of sustaining a colony. Radiation shielding. Colonies might need to be placed below the surface of Ganymede to take advantage of the natural ice and rock layers for radiation protection. Alternatively, large, thick shields made from water ice, or even special materials that block radiation, could be used in habitat construction. Terraforming Ganymede. Terraforming, or altering Ganymede's environment to make it more Earth-like, would be an extremely long-term and challenging process. Given the Moon's lack of atmosphere and extremely cold temperatures, significant efforts would be required to increase temperature. Large-scale methods such as using greenhouse gases, orbital mirrors, or even nuclear-powered heating systems could be proposed to gradually increase the temperature. Create a thicker atmosphere. Methods to release gases like CO2, nitrogen, and oxygen to build an atmosphere would be an enormous undertaking. However, Ganymede's low gravity might make it difficult to retain a breathable atmosphere over long periods. Introduce life. The introduction of Earth-based lifeforms, including plants and microorganisms, would likely be part of any terraforming plan. However, the process would take centuries or longer, and the potential impact on Ganymede's existing ecosystems, if any, would need to be considered. Possible uses for a colony on Ganymede. Colonizing Ganymede would not only be about establishing a permanent human presence but could also serve various scientific, economic, and strategic purposes. Scientific exploration. A Ganymede colony would be in an ideal position to study the Moon's interior, its magnetic field, and the potential for subsurface oceans. The possibility of finding microbial life in liquid water beneath the surface could be a key scientific goal. Mining and resource extraction. Ganymede's icy surface might contain valuable water that could be used for supporting human life or converted into hydrogen for rocket fuel. Its rock composition might also yield valuable metals and minerals. Strategic location. Being located in orbit around Jupiter, a Ganymede colony could serve as a hub for future space exploration missions to outer solar system bodies, including the moons of Saturn, Uranus, or Neptune. A base there could also serve as a launch point for interstellar exploration. Timeline and feasibility. Short term, next 50,100 years. In the next 50 years, sending probes to Ganymede for scientific research is the most realistic goal. Space agencies like NASA and ESA are planning missions that could reveal more about Ganymede's potential for hosting life or becoming a future site for human exploration, e.g., the upcoming JUICE mission by ESA. Medium term, 100,200 years. With advancements in space travel, propulsion technology, and life support systems, it might be possible to send human missions to Ganymede, perhaps with an eye toward establishing a temporary research base. In this time frame, technology for mining ice, producing energy, and creating closed-loop ecosystems would need to be developed and refined. Long-term, 200+ years. A full-fledged colony on Ganymede would be possible only after many breakthroughs in technology, including sustainable life support, radiation protection, and large-scale energy generation. It would likely take centuries before Ganymede could support a permanent human settlement capable of self-sufficiency. Key agencies and future projects. NASA's Europa Clipper and ESA's JUICE missions. These missions are expected to provide valuable data about Jupiter's moons, including Ganymede, and could help pave the way for future human exploration. Private sector efforts. Companies like SpaceX and Blue Origin, which aim to make space travel more affordable, might play a crucial role in reducing the cost of interplanetary transportation, making future colonization of Ganymede more feasible. Conclusion. Colonizing Ganymede remains far in the future, with numerous scientific and technological hurdles to overcome. However, as space exploration advances, it could become one of the most fascinating destinations for humanity, offering the potential for scientific discovery, resource extraction, and deep space exploration. For now, Ganymede remains a target for robotic missions, but human presence might become a reality in the distant future.